Well, I guess it's about a month and a half ago, Jerry and Chad called up and said, hey, you haven't been out in a while. They knew it. I'd moved back to, I live in Tennessee now. I'm back home after 45 years in the Army, with the Army, back in Franklin, Tennessee, and have the old family farm that my grandfather bought in 1932. He was Wendell King. Then my dad had it. He was Wendell King. And I'm Wendell Christopher King, and I have it too. So we got 100 years on our family farm. And my son lives there with his chickens and his goats. And it's good to be home there, but it's good to be back with you all. I always enjoyed this. So when these guys called up and said, hey, how about coming back and talking with the group? I was like, oh yeah, I'd really like to do that. And then they said, well, we could do it on Zoom. And I said, oh, I really don't like doing that. I'm not good at that. I need to see your all's faces. I need to have contact. That's the part I enjoy about teaching. I taught for a long time. I taught at West Point for 14 years. Best job in the world, by the way. Pretty good students that behave themselves. They do their homework. You know, it was a great job. But I really, really enjoy the sharing the information after I gather it up and spend the time. And certainly I enjoy doing it when we're talking about something that is as critical as climate change and what that is doing to the earth that we've been on. I started this in 1991 when I first went to West Point to be a teacher. I have a PhD in environmental engineering. I was teaching engineering at West Point, and I had spent 20 years in the Army already as an engineer, as a medical service corps officer, doing humanitarian ops in strange places of the world. Like Rick and I were in the same place working on Rwanda in that humanitarian crisis. But that's one half of my life. The other half is a PhD and a teacher and a scholar. And you have to have scholarship if you're teaching at college. You're supposed to have something to share with the people that you've developed independently through research. And I wasn't going to do the research that I got my PhD on, so I was looking for a topic at West Point. And there was this thing called environmental security that was just starting to be talked about by people like at Harvard and Oxford University and places like that. And I'm going to explain what that's about at the end of this discussion, because that's where the rubber meets the road. This is the so what of climate changing. How does that impact human security and become environmental security risks for people in different places and maybe for the whole world, the one we're going to talk about here. So there was my Dr. Jekyll and Mr. Hyde, an Army officer, now wants to talk about, I guess now I'm woke. I didn't know I was woke then, but now we have a term for calling those kinds of things. But it fit together, and it's been what I've been working on for the last 45 years as my primary focus in research. So when Jerry and them called, I said, I'd really like to go back, but what do I have that I want to talk about that's new? I've talked, well, it was 7 times, I think Jerry counted up. I've been down here on different topics. So what is there that's worth talking about? Because I'm not going to come down and do the same things again and again. Mm-hmm. And I don't know exactly why I came across it, but the research for climate has been led by an organization called the Intergovernmental Panel for Climate Change. It's founded by the UN. I'll get into the details of that. And they did that in 1988. And over the last 40 plus years, they have continued to work. That group has been in place and doing work on climate change. And I have followed it all the way through 6 major reports. A major report's over 4,000 pages. Each one of them. There's 200 countries involved in this and over 2,000 scientists that have been dedicated to this for up to 40 years, depending on if you've stayed the whole course of life. But what have we really learned? What have they accomplished? Nobody had kind of stopped, and certainly they can't do that for themselves. You don't, well, unless you're in the government right now, you don't self-judge how your work is going. Yeah, we're doing pretty good. Yeah, we've heard that. Oh, it's the greatest we've ever had, ever been. So I thought maybe I would just look and see what was in the history of the chronology of what's going on in climate change through the IPCC's work, and mainly just the science side. As you'll find, there's 3 parts to what they do. but I'm the scientist and I'm going to stay with that because everything's based on the science. You don't know what options you have to mitigate, to adapt, to try to react to the bad things that climate change brings until you know the science well. And that was just the complaint when we started, right? Well, we're really not sure about stuff. And some people have lived with that for the last 40 years. Well, we're really not sure about stuff. You're going to find out that's not true. So I think this is a good news presentation because you're going to find out my bottom line up front, as Army people will always do it. The IPCC was an amazing accomplishment. It really was amazing how you got 2,000 scientists from 195 countries to agree on things. And they don't agree on something unless it is dead solid, unequivocal. They don't go with 50-50. And that's a pretty amazing thing. So I want to show you what we found out in the last 40 years. Now, it's a negative thing, but we'll put a positive spin on that. The IPCC was an absolutely great accomplishment. What we've done with that is shameful, pretty much, in my view. So let's go. First, all right, let me get there. I always have to introduce myself. That's me. I'm the guy in the back. Actually, when this was done, it was 2017, and that actually came out of the Kansas City Star. It was there. The Army had just issued a climate report on what we were going to have to do as an Army to protect ourselves from the adverse effects of climate change. A lot about what the operational limits we were going to get in the places we go all around the world and how climate was going to affect that. So they came out with this, and I was the left-wing bleeding hearts liberal. Now, well, yeah, we could change the time. But I've shown this 4 or 5 times, so I have to start with that. Here's what I'm going to try to accomplish. I am going to start and go really to the very basics of what climate change is and the fundamentals that we started with in 1988. What was the baseline of what we knew we were sure about in 1988? Then we're going to go over the process, IPCC. It's important that you understand the process they followed to see that we can have confidence in the results that they produced. I mean, anybody can talk about anything, but, you know, there's this wonderful lady that used to run University of Kansas, the president of Kansas out there for a while. She says, you know, in God we trust, everybody else show up with some facts. Then we're going to look at the methodology that developed over the 6. They didn't know what they were going to do at the beginning, but over 6 different developments of new reports, they grew a robust process so that they could take all of this data, go through it in a logical way, and produce good findings and recommendations based on science. And then this is the last report. It came out in 21, but a report actually comes out for about 2 years. The science report is issued, then they look at the adaptations and modifications as recommendations, and finally we look at mitigation, how we're doing on being able to mitigate the rate that climate change has had. And then we're going to have a discussion about what do we do with all this. So that's what I hope to accomplish. Chad and I always have this discussion like, all right, are you going to take questions? I have to take questions. We'll keep them short, but if there's something that you don't understand, there's no sense in going on through there and leaving that untouched. So if you have them and I can answer them, I will do that. So basics of climate change. That's just a word description. Weather is the day-to-day thing at a particular time, and climate is that averaged over a place, over a time, over season. That's all climate is. And we knew that greenhouse gases, I'm going to show you those in just a minute, were the reason climate changes. This goes back to about 1750. A guy named Fourier, if you did math someplace, there's a Fourier transform. Same guy, obviously a really smart guy, without any instrumentation or anything. He figured out that, you know, the reason it's warm on the surface of the earth is because the heat hits the Sun hits the surface, it bounces off, and the heat's absorbed by the atmospheric gases. Now, he didn't have a gas chromatograph, he didn't have anything, but he's just a smart guy that figured that out in the 1750s. By 1889, 1890, a guy named Arrhenius actually put it into a mathematical equation. He figured out the relationship between CO2 and temperature in the atmosphere. He wrote an equation about it. We still use that same equation. We still teach it to our students because it's the best thing we've got from that. He got a Nobel Prize for the thing in 1903. But if you think about it, that's not that long ago when you think about science, the history of the Earth. We always think about things when we talk about ecology and the Earth scientists. We think in geologic time. We don't think, we don't think in 100 years doesn't mean anything. But that's in 1903 is when that came about. He didn't even ask anybody for that Nobel Prize. So climate change is simply, if you take a 30-year period, and that's usually what we do now for the weather-climate relationship. 30 years, okay. What was the temperature for this day under these conditions at this time of year? What would the climate we would expect? That's what you hear on the average daily temperature is. We've only had data to do that since 1850. We didn't have enough places that we measured these things until 1850. So when you hear that this is the hottest day in recorded history, that's 1850 to today. That doesn't go back any further than that. We have science that tells us what it was like 200,000 years ago, but we don't have data. So when you listen to what people are talking about, sometimes we sensationalize it by trying to say, the greatest, we hear the greatest of all, and that's only 1850 when we're talking about actually measured data about what we know about what the temperature was, how much rainfall there was, those kinds of things that describe our weather. And here's the big one. This is a thermodynamic system. It is all driven by the energy from the sun, the amount that's absorbed, and then the relationship of how that greenhouse gas resides in the atmosphere compared to the greenhouse gases that are lost over here. There are natural systems, sinks we call them, that takes greenhouse gases out of the system. At the same time, there's natural systems that put greenhouse gases in. Then there's the human impact, which is the greenhouse gases that we are creating and adding to the system. And that's the problem. We hadn't had very high concentrations of that till like the early 1800s. And then modern society needed the energy to drive modern society and the other industrial chemicals and those kinds of things. And those are the sources of the greenhouse gases. I'm going to talk about those in just a minute so you understand that. But it's not a hard equation until you figure out how many variables go in there that you have to do the math with. And at the start of 1988, we didn't have this equation. Certainly, we didn't have everything you need to put in that equation to solve it correctly, to get an accurate final, what is the change in the heat over a year's worth of adding greenhouse gases to the atmosphere minus that's being lost. We didn't have the ability to do that. We knew sort of what it looked like, but we didn't have the math and we didn't have the science background to do that. And that's the thing that the IPCC took on. We need to do the science in an organized and defensible way. So in 1988, the United Nations and the World Meteorological Organization formed the IPCC, 195 member countries. Every country that was in the UN at the time joined up, and 2,000 scientists volunteered. This is all volunteer time, but they're academics. They're supposed to be doing those kinds of things as part of their job. As being educators, you got to have something to show. This is, the second line is a quote for the actual mission statement for the IPCC. I'll let you look at that. I don't read slides to people. So over from 1988 to 2022, 6 major reports have been put out. Voluminous, massive amounts of information have been collected, analyzed, and I'm going to go over the process because I told you that's really important that you understand that it is defensible, it's trustable, it's best of anything I've seen. And they also formed this thing, a conference of parties, every year from 1995 on. They have an annual. Every country sends a senior representative. They have a meeting. They're supposed to make decisions about what we should do as a world organization to deal with the problems climate change is causing. Quite honestly, I think that's been a failure because net result is we have not gotten a world solution or even a major group of people that will take on trying to address it. The lifestyle changes, the changes that have to be made to be able to deal with it. They're there, we could do it. It's the will of the people that really determine that, the will of the politics that's there. And of course, if you haven't kept up with it, the United States is not a member any longer. That was one of the first things we did early in the presidency we have now is we dropped out of this system. Oh, of course, we dropped out of the World Health Organization and several other things.
And our data is not being added?
What?
Our data is not being added?
No, we're not sitting on the cop. Our scientists continue to do if they can get the money for it, because that's some of the money that was taken away from Harvard, Princeton, Yale, Kansas, and these other places that do this research. IPCC in and of itself, maybe its individual members in their own activities do primary research, but the IPCC does not explicitly do research. It takes in research from the whole world. It collects it up, and then it goes through and first with the science to try to validate what's there. Only validated research is going to go into a report. There's lots of stuff there. That doesn't mean it's bad science. It's not validated yet. It may be in the next report or the report after that. But they're very, very rigid about that. If they cannot get to a reasonable, and I'm going to show you how they make that judgment, I think that's very important. We need to have confidence intervals, or we call them error bounds sometimes when we deal with data that's a little bit fuzzy. Like if you have a computer program, it says the number is 1.87766, and then it says plus or minus 10. That's the error bound around the number. What we're really worried about is trying to compress that error bound as much as we can to say that this is an accurate number that we can then act on. We can spend our money. Each report, this is a critical, important thing here. A summary for policymakers. Then it has a physical science section. That's the one I read. I actually read one that was 4,000 pages. I don't read any of them after that. I went through and picked through. That's why this thing is so important. I'll come back to it. Then the second subgroup that's formed analyzes adaptations and vulnerabilities associated with the findings that have been verified by the science guys. And then the last section is mitigation for adverse effects of climate change. So 3 reports. It usually takes about a 3-year cycle to get them all out. So first the science comes out, then the vulnerability guys look at it, and the final version is, all right, what are we supposed to do? Well, that's a fairly complete process when you think about it. That's going through it in a very logical, methodical way to get to a place that we should have the ability to make decisions from. And that's, if you study the science of decision making, that's a pretty good system. So you get a piece of data and it comes in and it's the only one about how fast is the sea level rising on a decade basis. You get a piece of data that, or maybe there's 3 people that have reported on that between the 2 study reports. It comes in. These are the opportunities there. It could be limited evidence and low agreement among the evidence that comes in. That comes in and we'll get something down in here like unlikely, very unlikely, or exceptionally unlikely. Now more data comes in and you have another report and it starts to verify and validate some of the findings from previous studies. Now we see that we have medium agreement and medium evidence of that. And now those will be listed explicitly in every report. They will try to list their findings as likely. You see them here. Now, if you get up here in this one corner up here, there's a tremendous amount of evidence and they all validate the same basic finding. Now you've got a place where you can say it's virtually certain, very likely, and you're going to see several of the things I'm reporting are unequivocal. There's a 100% chance that that is the real deal. Those are accurate, consistent facts. And from really not in the first one, but from the third and fourth and fifth and sixth one, everything they report is validated through this kind of, so you'll see a italics, very certain rating on anything they put in there that's a basic finding or recommendation. And you can take it to the bank that it's gone through this process. Now understand the scientific peer review process. I describe it this way. You develop your study. You've done your work in labs for 3 years. You put it into peer review. You send it to the journal that publishes on meteorology or air pollution or something like that. They're going to find 15 people that probably hate your guts, that want to look at your project, at your piece of evidence and invalidate it. They want to find it to be wrong. So if you go through that process and you're validated by 2,000 scientists from all over the world, the likelihood that they gave you a go just because you're cute or something, that's not the nature of the beast. It's a group of very, very smart pessimists that look at these things and go through that. So when they're able to report something as unequivocal across 195 countries and 2,000 scientists, that's very, very, very strong. So what I'm going to do now is I'm going to put up a slide of each of the 6 reports. And what we're going to do is we're going to follow the bouncing ball. We're going to look at first, we're going to look at the greenhouse gas emissions. The best way to really represent that is in the CO2 levels as they have grown over the years. The reason because it's 60% of all of the greenhouse gas emissions are CO2. There's a bunch of other stuff, and I've got a slide that's going to show you those, because each one of those has a different rigor in how much it changes the temperature. CO2 is the baseline. So if 1 pound of CO2 absorbs this much energy, you're going to see there are things that absorb 20 or 50 times more than CO2, but there's not nearly as much of it. And we'll talk about how we keep track of that. So in 1990, we believe that the greenhouse theory was correct. It does kind of act like a greenhouse. We believe that these were the greenhouse gases: carbon dioxide, methane, nitrous oxide, chlorinated fluorocarbons, water vapor, and a whole bunch of the complex chemicals that we created our own for different reasons, and are listed in the atmospheric concentration in parts per billions and parts per trillion. But they're still very strong greenhouse gas absorbers of energy. So we try to keep track of all of them. By 1990, we believe that the climate had changed 3 degrees centigrade in 1990. I want you to keep track of this one. Put this in your mind. This is like that test they give us to find out if we're going senile here. Remember, in 1990, they predicted the climate overall would increase by 1 degree C by 2025, last year. All right, you got to remember that now. Here we go. Well, we didn't know the list was much longer than that, but I picked out some of the first ones. The sinks for greenhouse gases, we knew qualitatively where it went. Carbon dioxide is absorbed into the ocean at pretty high levels. And that's why the ocean acidifies, because it's extra carbon dioxide. But the rates and how those mechanisms, there hadn't been any study of that because we didn't really need any We didn't need an absolute value for something. How the ecosystems were going to be affected by climate change. So if it warms 3 or 4 degrees in the Arctic, which it's doing, how is the whole ecosystem going to react to it? The impact of clouds, we hadn't measured it. We knew what it was. We know the clouds reflect the energy from the sun back and doesn't hit the earth. But a lot of that hadn't been studied at the quantitative level, only at the qualitative. Polar ice and loss of ice was another one that was, I'll give you a heads up. This is the one they probably missed on the most. They underestimated that when they thought about it in 1990. We didn't believe it was going to go away at the rates it has, both in the polar ice and on the ice sheets like Greenland and in the other ice sheets like the Tibetan Plateau. You all remember it. Tibetan Plateau is one of my favorites to talk about as far as when we talk about places where it's really going to get bad from climate change first. And we believe that extreme weather was being driven by climate change or being affected by that, but we didn't have a quantitative. We couldn't really say anything with confidence about that. And that's where we were in 1990. So you can understand why people didn't want to jump up and say, let's change the world because of climate change. But IPCC took on the job of answering the question. So here I promised the greenhouse gas. So there's CO2, that's methane, that's nitrous oxide, fluorocarbon, another kind of that. So carbon is 1 HCFCs, 1 pound of HCFC compared to 1 pound of carbon. This is 1,500 more virulent in absorbing the energy from the reflected heat energy off the surface of the earth. Thankfully, those are in parts per trillion. Well, you can see there's only 0.5% of all the greenhouse gases were there. Now, to do the math, what we have done is we have created what we call a composite greenhouse gas. It's based on carbon. So you take the 1,500, multiply it by the 0.5, that gives you the number that effects that you get from HCFC. And so some places we report CO2, some places we report the total greenhouse gas effect in CO2 measures. But since 61% of it, if you follow carbon, and that's why I'm going to do that as my data going through. If you follow carbon, you know where it's going. And carbon is the one we continue to add to and add to and add to. Okay, so the second report, it went from 350 to 360 in CO2. And that's over 4 years. Greenhouse gases concentrations continue to rise. We actually got a good one. The aerosols that we were putting into the atmosphere through industrial pollution and stuff like that actually have a cooling effect. So we had something else we had to add into the sinks we didn't know about when we started. But it wasn't all bad news. Climate's changed over, very, very general findings because there's not enough data yet still to start raising it to high confidence level. But we're making progress on what we know. I mean, these things like today we go like, duh, hit your head, Homer. But as a scientist in 1995, you didn't have the data that you could actually hit your head. Big one here, and this is one we're going to have to talk about. That's the independent variable, and it's the 800-pound gorilla. How much more greenhouse gas emissions are we going to have next year and the year after that and the year after that? I have to have some way to manage that. And they came up with a beautiful way to do it. If you look, I'm going to go back here. Over here. What you see is the data reported for 2 different levels of greenhouse gas emissions in 2000. What they did was they took, here's what we're doing today. They went, what we expect to do if we continue to add greenhouse gases at 2 levels. So you got 2 levels above that level of greenhouse gas emission. And they went 2 levels below. So they did the analysis over a range of 5 greenhouse gas possibilities. The last one was, the smallest one would be this one, which was, what do we have to limit it to achieve a goal? We wanted a goal to try to not go over 1.5 degrees C by 2050. That was a goal that we started out with but
Are we already there?
yeah.
For
But
1 year.
we're not at 2050 yet, but we're really close. We're above that right now because we added more than the minimum. But this allows you then to say, what are the what ifs? What if we do this? What if we do that? And it's a really, really brilliant way to actually allow you to continue on with evaluating adaptation, mitigation, and those kinds of things. And they came up with that about in the AR3 time level because they knew they were struggling with it. We knew, go back here. We knew we had to have a way to be able to start telling the political and the leadership of the world, it's time to act now because of the question you asked. If you look at the greenhouse gas things, they also have a long residence time. Carbon dioxide stays in the atmosphere for 100 years if it's not captured by one of the sinks. So I like to compare this. It's, the time value of money and compound interest. Well, this I look at as the compound interest on your credit card. It just keeps getting worse and worse and worse if you don't pay the bill. And that's what happened with the more greenhouse gases coming in every year than the sinks will take out. And that's what we found out. And you'll see in a slide in a minute. Right now, our estimate is that 53% of the greenhouse gases that went in over the last couple of years were taken out by the sinks. The sinks don't get more productive the more we feed it greenhouse gases. And actually, at a certain temperature, it goes the other way. And some of them start failing, particularly the biological systems, the trees and the vegetation and stuff. They get less in areas where it's really getting warm. But we now have that data. That's the great good news that comes out of all of it. But the major uncertainty we would do. Now we're getting in by 1995, a lot of money is going into computer modeling, building a model that will be predictive of the future. Now, to build a model that predicts the future, what you do is you take like 100 years of data we've had past where we've got good data, and you build a model that can get those numbers wrong. Then you've got some certainty, if the science is still valid, that you can use those to predict what's going to be in 5 years or 10 years. And this work started in about the 1995 range. And the reason it took that long to get to it, because that's expensive work. It was back then anyway. Now with computer systems and stuff that we're driving now, it would have probably gone a lot more efficiently. But modeling, there may have been one general model back before that. The first model was built in 1967, and it was a very rough model. Now we're getting to stuff. Did you notice that now on the news, you can see the little spots on the map at 2.5 hours, there's going to be rain here. We didn't have that 20 years ago. Mm-hmm. That modeling has actually what produced the better weather data that we have now, because they use those. There's the European model, there's these other models, and which one's right and which one's wrong. What IPCC does is it takes it and puts them all together. And it looks at them and it will say, here's what the models predict, all 5 of them. And then it gives you the error bounds. The worst model says it'll be here. The other model says it'll be here, but it'll all be within this range. And that range is getting smaller and smaller. That means it's more and more accurate for predicting the future based on the modeling. Because when there's models that are competing, they feed themselves to improve. Large, rapid climate change systems remain very difficult. We're still having trouble to tie it to like the ocean current collapse, the Greenland ice cap sliding off into the water, and we have 100-foot sea level in about 2 weeks. Those kinds of things, you still did not want to commit to significant findings on those. There was some more data, but they were not validated to the point that was in the upper right of my confidence interval predictive slide you saw. Mass ecosystem destruction. We feel it. Somebody in there probably knows how many endangered species we have lost in the last 10 years and stuff, but it's a huge number. We're doing it in percentage now. We don't even do it in numbers anymore. 40% or something of the whole world species. And nobody would disagree that climate change is at least complicit in what's going on there. It may not be at all because there's the other human effects, and we're pretty much our own worst enemy in that regard. But still, you're not going to see in 1995 results being said, find that you need to act on this in 1995. But so yeah, here I brought it back. So at the lowest, we could expect greenhouse gas to be emitted. This is what the warming looked like. And so you were getting slightly less than 2, but still busting 1.5. But if we did the worst case and we kept emitting at increasing rates that we were seeing, and I'm going to show you some of that data in a bit. This is what the world looks like. That's 6 degrees centigrade. By 2080? No, 2100. 2080 to 2100. That's what they were predicting with the models in 2000. It's our choice. It's really down to that. It's that choice. Can we find a way to reduce? Which one of these are going to live with? We're not going to live with this one, because that prediction for those kinds of temperatures make the Earth uninhabitable. So now we're into 2001. By 2001, we were seeing an acceleration in the rate that global warming was occurring, because it's the accumulation of greenhouse. It's that credit card effect again. We continue to increase the amount of money, the number of greenhouse gases we were collecting up in the atmosphere. So it has to accelerate. It's called exponential growth. And there was enough evidence to start confirming those kinds of things in the 2001 report. And now we see extreme weather starting to be documented, enough data and enough people working on extreme weather that we can start making some valid discussions about how much it's going to increase tornadoes, how much it's going to increase cyclonic action in both the Pacific and the Atlantic Ocean. We're just up to 368 parts per million on, but we're getting better at it. Watch. More hot days. See, look at this. The relationship between extreme weather hazard and human activity are far from certain.
Or more certain, not far from.
Excuse me, are more certain, yeah. Compared to what we said is we think there's a connection, but we couldn't talk about it in one. This was a significant one for the 2001. Possibility of ocean circulation systems irreversibly shutting down. That's really not true. It would just take about 20 or 30,000 years for them to reestablish themselves. 2007 is the next report. It's warmed to 0.74 degrees centigrade. Carbon's up to 379 parts per million. And it exceeds a level that we have been able to measure with science, not measure. Nobody was there then, at 650,000 years. At 379. Greenhouse gas emissions have increased by 80% at what's in the atmosphere from 1974 to 2004. And we were predicting for the next 2 decades, it was going to be 0.2 of a degree per decade. confidence intervals are up to the highly likely stage. More than 90% confidence that those are very valid. And now we're going to start talking a little bit more about the risks and threats. Threats to water resources, ecosystem, food system, coastal impacts, and human health because of disease. And are you going to talk about, no, you're talking about plastics. Rick does a beautiful job at putting it all together of how it affects human health. We did one together once. That was the most fun I've had. It really was. Here's the science, and here's somebody who actually knows what's going to happen. All right.
Could you go back one real quick? I'm so.
Sure.
You were fighting over Dr. Rick.
You good?
Okay.
No, that's fine. Congratulations, we hit 400 parts per million in 2014. Yay.
America.
Well, yeah, we're going to talk about food there. We continue to add at very high rates. And there's more and more looking at sea level rise, ocean acidification, and extreme weather. Now they're rated as extremely likely to be driven by climate change. And the risks now, food production systems, livelihood, health, economics, biological systems, and the physical system are all being very strongly impacted by climate change by the time we get to 2014. Please, Jerry.
Do you have any tracking of the numbers for the pH of the ocean?
I have not tried that. I bet you somebody's got it out there somewhere. The oceanographers have got it. They're big. It's localized though.
Yeah.
It's different places. It's different rates.
Yes. It's gone down a couple tenths of a pH unit.
And there's a critical point in there where it kills coral, takes out the food cycle.
Well, anything that's shell or
Crustaceans.
calcium based, after we get too acidic, it can't form anymore.
Yeah. And the heat kills, changes particularly for coral. Please, sir.
So I think that kind of fed into what I was questioning my mind was pollution and all of those things are not really climate change conversation.
No, they just pile on.
pH levels aren't climate change. I mean.
Yes, they are. pH is climate change.
pH is mostly climate change.
pH
CO2
CO2
produces carbonic acid.
Certified the
Yeah,
in freshwater too.
because there's a massive amount of.
Temperature change? I guess I'm trying to discern in my mind whether this is kind of temperature driven or smog, polluted water, things like that kill species and.
It's actually all of the above.
Yeah.
Those could have their contributions too.
That's all being documented in all.
It's documented, but really what we have measured for the pH particularly, that is so driven by the amount of CO2 that's absorbed out of the atmosphere into the ocean that overwhelms everything only on that one particular instance. That's the biggest natural sink. There's gigatons and gigatons per year going into the ocean. Without mitigation, we will reach 3.7 to 4.8 degrees centigrade above 1850 to 1900 level. That was by 2100. We would be that little red map that you saw that I showed twice by 2100. It said 2081 to 2100. This is the seminal report. This is the end of the line here. They're still working. There will be another one they've already formed up about how they're going to organize and what they're going to do with the AR7. And I've been following some of that. We expect it to be, they predicted as almost unequivocal. So it was the very extremely likely corner, 2 degrees by 2041. So we're going to bust the 2050 about 10 years early for 2 degrees. Carbon, look at the jump. That's the big problem. We're accelerating because so much more is being added And the rate that's being taken out by sinks is not going up, it may be going down. We haven't confirmed that part yet. Carbon CO2 equivalents, that's the omnibus one. 59 gigatons, nearly 30% increase since 2000. So we're supposed to be trying to control it, and we're accelerating in the other direction, like the actual measured amount of total greenhouse gases we're putting in there. Our estimates, I told you 53% now, our estimates are that goes down as the temperature is warming up. And it'll be only 30%, and it'll only be 38% of a bigger number, meaning it's leaving more in the atmosphere the next year. Virtually certain that droughts, flooding, and those things are being impacted by climate change. We have gone from we don't know to virtually certain. I mean, that's really bad news, but it's great news that we actually know the numbers now that we did. Oh, at the start of this period, we had only, opinions about things. And this one here, I'd already told you, what we misrepresented and misestimated was the rate of loss in glaciers and ice cover on the land and ice cover on the poles. We just didn't get that one right early on. It was underestimated significantly early on. It went from something, it was more than double than what we thought it was initially. Right here, methane. Methane's not a big one as far as the total amount on an annual basis, if you saw. Methane is 20 times more impactful on energy absorption than carbon. But the big scary one, and you probably, if you've heard anything on some of the, if you watch PBS sometime, there's some research that's going on very, very, I think very actively of what happens if the permafrost melt. There are so much methane that's trapped in the permafrost that it could overwhelm the whole system. Because we will have one large release at one time for something that's 20 times more absorbent of the heat energy as carbon. And instead of having 59, we will have 1,000 gigatons that will come out of that, because the whole northern climates, Siberia all the way across Canada into Alaska, huge, massive amounts of permafrost. It's melting very, very rapidly.
That's a tipping point.
There's the tipping points. That's one of the biggest ones. The Greenland ice cap is one of the tipping points, and the Atlantic Ocean current collapsing are the three. Is
We're even generating a lot of methane down in Antarctica.
Yeah, because it's got frozen. Yeah. So those are but that's in the soil that's permafrost is apparently massive, because it was, 100 million years ago, it was a green lush forest, and all of that stuff, that methane is a byproduct of biodegradation in the natural system. That's swamp gas for some people. 3 to 3.6 billion people we expect to be severely, highly vulnerable to food insecurity, water scarcity, extreme weather, and health impacts. Half the world will be immediately affected, and the ecosystem damages are irreversible. These are all things that are at very high confidence level, as you're going to see right there. So this was my big finish on this part of it. Here are the major climate change factors. This is the stuff. Warming, sea level rise, precipitation changes, snow and ice cover, extreme weather, droughts, dry. These are the ones I created when I was doing a strategic analysis of the security threats, national security threat strategy. These two down here, keeping track of what we know about the natural sinks, because that was strong unknown when we started in 1988. And then a way to keep track of going from 353 to 430 and just in the carbon dioxide. Now, that's not equivalence. That's the carbon dioxide level that's measured on the top of Mauna Loa volcano in Hawaii. That's the place we get our carbon dioxide data we use. That thing was put in.
So now we're not funding it anymore, right? The funding is gone for that, or is that?
I don't know who runs that.
I think somebody else came up with funding.
Somebody's gonna cover it?
Yeah, I think NOAA runs that.
They do, well, God,
Not anymore.
they've been decimated.
Yeah.
Everybody I knew that was working at that, they were, kind of like me, they're old. They could have gone away, some of them 20 years ago, but they love their job. They love doing what they were doing. They're gone. They were just blasted out. So you can have an organization, but if you empty the people that know what the hell's going on, you're not an organization. So then I followed them all the way across and look where we ended up. I'll do it from over here. You guys look at the outside column over there. Okay, we got to an actual temperature by 2023 of 0.109. Unequivocal. That's what the U means. 100%. Take it to the bank. We had gone from, in AR5, we thought that the sea level rise at 1.9. Back here, it was at like 1.5 millimeters per year. Now it's up to 3.7. All of it's human caused. The ocean would have actually gone down if it wasn't for the human influence. Precipitation, that's geographically dependent. Some places are getting more rain. The problem is it's a spatial and time domain. When do you get it? How much do you get it? What we're finding out when you have all this energy, it's released into larger storms. So you get a lot more rain in certain periods and a lot drier in the warm periods when you need the water if you're an agricultural sustainment kind of culture. So it's the worst of worst. You get floods at one time and then you're dry when you're trying to grow your food. And that's really what it's producing. And that's what the data shows at the very likely level. The losses in sea and particularly in the Arctic will be clear of ice by 2050 for the summer periods. Some of it will build back up depending on how the winter goes, but we're going to have an ocean, an extra ocean to have to deal with. And as a security issue, that's one that we look at. Yeah, the whole north is opened up for the Chinese, for the Russians, for sea passage, because it's a better way to get, when you fly from here to Tokyo, you go over that area because it's the shortest route. Same thing for the boats. So instead of the Panama Canal, they'll all be coming through. Oh, and by the way, there's a lot of oil up there and rare earths and who owns that? And that's a different world. And you see virtually certain for all these other things now, from having basically a 50-50 chance of it being right or wrong. Over the 40-year period that the IPCC has been doing their research and doing their work and due diligence. And we've gone from natural sinks that were taking about 70% of the greenhouse gases out total to 38% now. 38%, remember, of a much larger number. So a doubling at least of the amount of buildup we're getting on an annual cycle. And it would actually, if we hadn't had human interference, the temperature would have gone down over the 40-year period that they've been doing the IPCC.
We were talking before class about micro-ish cycles.
Yes.
That we should be in a prolonged cooling period, fortunately, or we'd really be in hot water.
Yeah, but here we're talking about a period that should be in the thousands of years.
Yeah.
A couple of thousand years here. This is all in 180 years. That's the reason we always knew when we started that we were right, because the rate have changed. There is nothing that would ever predict natural systems that would change the rate of temperature increase over such a short period of time. That was always the big clue. That was the hit your head, Homer. How can you say it's not that when we've warmed this much in a period of time that it shouldn't have been almost measurable? Almost we shouldn't have been able to see much different over just 180 years. Come on, that's nothing. So that's been, I want to go over here and now work with these guys a little bit in my business, which is environmental security.
Chris, but,
Please go ahead.
on the methodology a little bit. I've read where when there are significant economic downturns, like in COVID and the rest, there is a decrease in greenhouse gas production.
That's true. But it lasts a year or two. It doesn't last very long. And sometimes what we've seen the last two, all it did was just went flat for a year. It didn't actually go way down or anything like that.
But
It goes flat.
Yeah, but if the economy, if it keeps getting warmer, and climate change increases, at some point that's going to affect the economy.
It's going to break it.
And then, will that be a feedback that, gets factored in, that, it may actually reduce the.
That's a good point, but let's think about that. So, all right, it collapses and now we're here and we're not adding greenhouse gases. All we have is a mechanism that'll slowly take it out. But that has to last for another 100 years. That's the problem is we've probably got a 50-year tail for where we are now till we start seeing any significant downturn in the actual changes in climate that we will see as we're not adding more greenhouse gases in there. We've already bought the farm for probably up to 2100. And that's what everybody keeps telling, okay, it doesn't, you can't shut it off and it's all gone. It's all good again. If you could turn it all off, and we know you can't do that. You can't quit producing energy. People can't starve for a while. You're going to see how, I'm going to posit something in the last slide, and then we'll have a discussion about that. So now I'm going to look at it from a national security standpoint. And this is environmental security, and this was the brightest mind I know. He was a Harvard educated guy that was teaching in Toronto when he got into doing environmental security. And in 1986, look what he said. National security, it includes, I was working on watershed when I first started this. I thought water was going to be the critical element that we were fighting on in 1991. I've been with the Corps of Engineers too long. I sucked the Kool-Aid down and all that stuff. But climate was right there when Norman Myers was thinking about that. Norman Myers was a social scientist. He probably couldn't, he couldn't solve an equation if life depended on it. But from a social science standpoint, it made sense to him. He's kind of like Fourier. He didn't know, he was thinking about things, thinking deeply about things. That amazes me. I look at some of the stuff that people thought about without any knowledge, and they got it so right. Man, must be something to be that smart. I always use this one too.
Yeah.
Because I was trying to convince military leaders they ought to pay attention to environmental security issues. You know how well that went. PH Liddell Hart got that one right. But what I didn't understand was that compared to talking to military officers, politicians, military officers are easy. They understand the bottom line and stuff like that. I haven't found any way that we've been able to convince politicians. And I will be apolitical there. I don't think our last Democrat, I don't think, I'm not talking about Biden. We didn't get that much progress out of it as a country then. We talked about it more. We put it in the discussion. We don't even have that now. So what I do is, here are the 7 deadly sins over here, and then I look at the key impacts that they have, and then I look at the security implications each one of those produces for a military. Because up to this point, I'm not sure this is valid anymore, when we had a major international disaster, natural or whatever it was caused by, and you dialed 911, the people who picked up the phone were the United States military. Because we were the only guys that could pick up a whole division of people and move them to the middle of Africa and support 1 million people sitting on a rock in Goma Zaire for 90 days, 180 days, for a year. They're the only people who can do logistics like that. They can provide ship medicine and food and people and engineers and everything you need to do that. There's just no other way to do it. So if these things are going to produce natural disasters, mass migrations, conflicts, it impacts what we do as a military. When we think about what are the missions, we're supposed to figure out what the missions are before and be prepared to go, not go, dang, what are we going to do now? But doesn't seem, yeah, you're right. We're not doing much of that. Silly me. Yeah. Silly me. So this is the kinds of things that we need to be planning. When I was at Command and General Staff College, that's a bunch of real smart majors from the Army, from all over the world. We have 125 countries that come to that college to study the art of war. And most of those guys spend their time on humanitarian ops because that's what they do for their country. They don't have all these other deposits. They go to their military for whatever they need, a peacekeeping, relief for people. They go out and farm if that's what you need to do to make your country more successful. And they are always ready for these kinds of things. They know it's coming in the third world countries, in the smaller countries that have only a military as their basic response mechanism. I guess the most stark example I use, I'm on a thing called the Global Military Advisory Council. There were a bunch of general officers from countries all over the world that got together on our own and said, this is a real concern from us as military leaders to be prepared for this. The leader of the thing is from Bangladesh. He's a 2-star general, chief of staff of the Bangladeshi army. And then he turned over and he became the head of basically their peace and security civilian authority. And I told him, I said, you're ground zero. Everything bad that can happen to you from climate change hits Bangladesh. They have the hurricane, the cyclones. They all live in the river valleys, down in the lowlands or on the coast. 35 million people are supposed to be moved by 2050 out of land that's now occupied in the lowlands in Bangladesh. They have the floods in the wintertime. It goes dry in the summer. Anything bad. And their population growth rates are the third highest in the world. That's ground zero for bad things happening to you. And that's the reason they were there. A general officer from India, their air marshal. We had the chief of staff of the Pakistani army. We had the Pakistani chief of staff of the army and the head of the Indian Air Force sitting at the same table. That does not happen politically, guys. I can't, at Command and General Staff College, I couldn't put the Pakistani officers and the Indian officers in the same room. Bad things happen. And the Indian officer stood up in the whole group and told us, we will never get along with Pakistan. And you got to understand the culture. We're too naive to really believe how deeply seated that is.
So where was it that they were sitting next to each other?
What?
You said they were.
We were in Brussels, we were in Amsterdam, we met all over the world, about 7 or 10 times. And our whole job was to go to all our officers, all our militaries, and to convince them to get their head out of their butts and start doing the proper strategic analysis and strategic planning so that they were ready when these disasters were coming, because we weren't going to turn it around. These disasters are coming. We could reduce the magnitude of some of them if we would start working on it, which we have not. We have not done anything.
So they would at the meeting in Belgium, but not at the staff college.
No, they couldn't sit together as fast. They would probably have been persona non grata when they got back. But these were retired. They were retired. This is the way I want to conclude. This is, I think, the most important thing that came out of the IPCC. So this is the temperature domain. And remember I told you the thing that told us, look at that. That is nowhere recorded. That spike for the last 100 years is nowhere in the history of the world. It's as we can judge it back for 3 or 4 million years. And I told you all the good work that went into modeling and creating a better understanding of what our future is going to look like. Well, these are the models that we have. This gray area down here is what the natural system would be doing, and we'll be booking along right here. And right here, in about 1990, what the human influence does when added to the natural system, you see there's space in there. There's no way with everything we know now that humans are not causing it because those two don't touch it anymore. The best understanding we have developed over 40 years of study, there's no way you can say that it was natural cause. Actually, it should have gone down if it was just now.
So humans,
That is amazing.
humans have lived for thousands of years, but the industrial age is. what's the last-
1850 on is where we
100.
saw it, 1800s, when we started creating new greenhouse gases and adding the magnitude of greenhouse gases
Burning
we do
coal.
for the energy to drive the industrial revolution and stuff.
Cutting down forests and burning wood.
Yeah.
And oil.
Oil. Yeah.
Okay, so these are the summary of findings that I have. What I want to do, let's see if this will work. Oh, I don't know. Can you hit that red arrow? See that red arrow in there? Oh, where's the computer? Oh. So China is now the winner. They produce more greenhouse gases than anyone individual. Oh, there you go. Okay. They just, yeah, that. Should click, there we go. And then you're holding that square bar over there. So here's where we are in the accounting right now. All the rest of the world is here. There is China. They have continued to burn massive quantities of coal because that's what they've got to drive their industrial revolution, which is 50 years behind ours. They're doing the same thing we did, but they got 1.3 billion people, excuse me, misspoke. And we did it on 150 million people. So is it that big? Yeah. This, we have made some progress. We started using wind. I love the sign that when I lived out here in Kansas, the energy company had a sign out there, how much of our energy was coming from renewable resources. And they put it up, it was 10%, it was 30% when I left. I saw a sign out at the airport that said the whole airport is run by renewable energy. On our own, we got going on it. Our own industrial systems, people saw that was the better future economically. They did the right thing. And now we're being driven not to it. Take all those end of pipe solutions off the cars, tear down the windmills. It's horrendous. It's worse than starting a war. So my conclusion was, what we have to do is we have to get a way that we can follow. Yeah, go ahead, Beck. That we can follow kind of the European model. They did that without great political influence, without too much. The people are more controllable over there. In the 1980s, we didn't get grocery bags when I was a young lieutenant over in Europe. You took your bag there and you brought it back. The waste and stuff, if you filled up what we would call a household container for the week, that was all garbage. And then it was processed through that they recycled what they could out of that in the 1980s. US is now a strong negative influence on any progress. Restarting coal is the one I hate most. I hate coal. I used to sample coal as a young engineer. I climbed the stack and we'd see if they passed their emissions tests on particulate. But what I noticed every place I went when I was working on a coal plant, there's a big pile of coal they're ready to burn. And over here, there's a thing called the ash pile. And it got bigger and bigger and bigger, and nobody's doing anything with it. And in that ash pile is beryllium, is mercury, is cadmium, is uranium. They had one of those break in Clinch River in Tennessee. The people cleaning up that mess, 55 of them died within 10 years from cancer they were exposed to in the cleanup because of the heavy metal dust. And they didn't properly protect them. They didn't put them in what we call the proper PPE.
It's
Criminal.
not considered hazardous.
That was
waste.
TVA, by the way.
It's not considered hazardous waste, by the way.
No, it was specifically
exempted.
excluded from any hazardous waste control. Absolutely. That's why I hate coal, because I know you're putting it up the air or you're living it in that pile. And those energy companies will just walk away from it someday and it's left to be a public nuisance. Like the old Superfund sites that were industrial sites that we had to pay to clean up because the companies declared bankruptcy or whatever. Please, Jerry.
I think I read recently that a lot of coals economically, even with this new infusion of
Don't you say clean coal.
support- No, with this infusion of support, economically, they cannot survive compared to renewables.
No, not at all.
I mean, they're gonna die a natural death. We just want to hasten.
We were doing quite well,
Yeah.
actually. TVA had closed 3 plants. They had to open back up. One of the big enemies was to run the new data centers.
Oh.
That's crazy. That's competing for our energy and our water. by the
Why
way.
can't you put solar
Massive amount
panels
of
on
water to cool
data
the
center
center.
roofs? Why can't you put solar panels on data center roofs and they can supply?
It wouldn't be,
their
it
own?
wouldn't be anywhere.
Wouldn't
enough.
be
There's
enough?
massive amounts of energy they suck down.
They want it continuous, the big thing is,
Continue.
Yeah.
it's the grid is the big.
I'm not sure we can afford that as a humanity. This,
Can you help us understand the changing of the EPA guidelines that were happening in the last?
we have a couple more guys.
Couple.
They just, the thing that we were working for CO2 and greenhouse gases on was a record of endangerment that was filed in 2007 and approved by the courts in 2000, the Supreme Court of the United States, that it was legal to declare CO2 as an endangerment because of its impact on climate change.
Okay.
EPA just rescinded that endangerment with Trump and his head of EPA, you know, the old coal and oil lobbyist that's the head of EPA now. And he put in, I think, another executive order to cancel the controls on cars and stuff, emission standards on cars.
Chris, we see over the years, countries starting wars out of national security interests. Do you imagine someday that countries will see that climate change is a significant issue and start wars over this and start bombing coal plants and those sorts of?
No, I think it'll be much more dramatic than that. I think it's gonna be, we're gonna implode on ourselves. I don't think one country can pick on another country. That's why, look at my last statement, and that's what we'll end on the discussion with. This is a completely unresearched, very biased statement. If we wiped out half the world's population with nuclear and contaminated, and put us all back kind of basic in the Stone Age mode, we might have a better chance of survival than we will have if we continue to just destroy irreversibly everything that we have built over just a couple of thousand years. Something to think about. I'm not.
You're serious.
What?
You're serious.
I'm serious, yes.
I was just wondering.
You remember there was a movie, what was that stupid movie? I can't remember the name. It was the Armageddon. The generals tell them it's only going to be 15 or 20 million people that we're going to kill. And at the back end, it'll only last for 30 or 40 years. It's the best thing we can do. I just kind of, I saw that little cut, they were running that, I forget who it was. I'm sorry, young lady, I cut you off.
I think
Dr.
the
Strangelove, yeah.
movie, Dr. Strangelove.
Yeah, that's it. Dr.
Strangelove.
Strangelove.
Wanted to say something else.
This would just went back to something you said earlier, there was a little note you had that about, the oceanic movement
Yeah.
patterns will
I
never go
can
back.
never
in.
remember what that's
You
called.
said, but, actually, I don't mean ever, eventually, you know, once humanity's been dead and everything happens, there was a book from, and he's a philanthropist and environmentalist, I think Bill McKibben, a book called, I think it was The End of Nature. And it came out maybe a decade and a half ago, and it's kind of a thought experiment in terms of once our species is gone, like just imagine the ruins of all of our cities and things. And it was a study of how plants will be coming back, how everything will be coming back. So it was kind of apocalyptic, a little dark, but a thought experiment that I think was kind of in hope that kind of, we're in a Christian church. So I mean, the tradition that we do not own the land, cannot be sold and owned forever. We can't ruin
We
it
are
forever.
sojourners.
Yeah, we
passing
just-
through.
Something's gonna come back.
We had an email discussion of.
Yeah,
that.
sojourners just passing
Yeah.
through.
Which, not to alleviate us from the responsibility of the anthropogenic
Jerry does a great.
destruction that we've done and caused. But at some point, something that out of our hands in life will continue in some manner.
Yeah,
But we need to do what we are called to as stewards.
yeah.
Sorry.
Jerry came up with a lot of good things. To me, the one that hit me most, Jerry, you saw, it was in Genesis.
Mhm.
Tend the garden. The
Mhm.
job was to tend the garden. And like, to me, like, that's it. You know, there it is right up front. That's mission statement up front. Let's go with it.
I was gonna point out that his slides are available upon request.
Yeah. And,
Just let me or,
Can
Yeah,
you,
go ahead.
produce those and disseminate amongst us?
we'll send them by email if you request.
And,
Yeah,
Yeah, send me an email.
I have
Forward.
taken and written a paper about this as I went through it. I got the idea that, I can't cover all this. I mean, we're running out of time now. And there's some details that I could add, I think that really strengthen. And I know all of you like to look at stuff. I do too. I want to sit it and study and figure out what works for me and what's, looks like yes to me. So I wrote a paper about it. It's probably going to be published in European thing. Harrison thought you'd say something like that in an American press right now, but NATO is putting a book together about, they have an extensive study. They have a center of excellence on climate change. It's actually run by the Canadian Army. And I know some of those guys, so, but I'm gonna put that paper in draft and let them post that too, if you want to read it. It's about 16 pages, has a few of the slides and it talks a little bit, probably more about the environmental security stuff, which that's where I am is if I had an expertise, it would probably be in that general area. I'm using my just general engineering knowledge for the rest of it, but that's the one I really studied for. And because I was a senior leader in the Army, I put those two together and looking at it at the strategic level. And that's why NATO was interested in it too. But I'll make that available for you. Please, sir.
I just want to make a comment on the tend the garden thing and agriculture in general. We're at a point in time, even here in the Midwest, where it's time to plant, and maybe you plant, maybe it just rains like crazy, cats and dogs. And then you can't plant because it's too wet. And then you plant late. And then you can't, your seed, you have to have a certain number of days to grow a crop. So maybe you have to plant a lower number of days, so you're gonna get less crop anyway. And oh, now it's summer, so it's hot and half, and it doesn't rain a drop.
That's all it works too.
I know, but even here, where we're supposed to be, almost immune to us, it's a problem. And let me get to fall, it's time to harvest, and now it's gonna rain again. And, growing crops, even right here, is problematic in like Central America or.
The rest of the world doesn't have their.
I mean, they don't have a chance.
To respond to that, more use of methods like cover crops
be great.
widely used, consistently used, with multi-species in the cover crops. All these things can
Be helpful,
smooth out the weather
You know, one of my best,
locally.
a little, not enough.
one of my best customers for my talking is the Farmers Union. I went all the way to the national annual meeting of, I was invited there after I talked to the Kansas group and stuff like it. Farmers have gotten it for about 20 years.
Oh, yeah.
They knew something was changing.
Choice.
They're the smartest people in the world because they feel it, they know it. They were, I remember one of my favorites, I gave a talk, it was at the National Union, this lady, she was probably 65 or so, she'd been farming all her life and her husband and all that. And she thanked me and said, you know, that was really good. I understand a whole lot more, but you're really scared. She was honest. Because they had already felt it. Their livelihood, their ability to do what they do, what had been hindered and was going downhill fast. And that was 20 years ago. They talked to those guys. But the rest of the world, no, they can't do any of that. And one of the things we were doing is trying to share with people the better methods for being able to sustain themselves in third world countries. We used to send people all over the world doing that stuff, and we would quit on that too. Sir.
Well, I think the kind of explosion of AI data center conversations, it seems like in the last, 3 or 4 months that just gone out.
I don't think they can plant anything.
Well, I mean, that's very scary. I mean, in the framework of what we've talked.
Can we afford that energy? Nobody's asking that question.
Right, and that just seems.
We're worried about all the things they could do it, but can we afford it? The water that they want to take water that people are using to grow crops and they get into their house and they want to run their cooling systems with it because they got a lot of money. And they got a lot of political influence. In Tennessee, it's bad. They're one of the biggest centers in the world they're putting in. We brought them into Tennessee. We gave them tax breaks and they're going to steal a whole town's water.
I come here tonight angry because I'm from Independence, Missouri. Maybe you've been watching the news.
No.
The city council just approved a data center at the 23rd and Bly Road, which is a wooded area near the Blue River.
Yeah, they gotta have the water.
20 million gallons of water just to set up the system for cooling. And they need a 2% replenishment because of evaporation every year.
Yeah.
I can't do the math, but just think about that. Like, Independence gets their water, I think, from the Blue River aquifers area. I'm thinking, what the hell are you doing? And I wrote a letter to the council and they all thought, no, we're getting so much kickbacks in stuff from the.
Ask the question.
Well, it's too late. They've already did it. And there's been a group that's just been we've sent over 280 letters to the council saying, don't do this. You're gonna be using our water, you're gonna be using our electricity. They're gonna open up the blue, the Blue Valley, power plant just down the road on Truman Road for this Nebius. Company's Nebius from Amsterdam. No, Amsterdam, Netherlands. Then they're coming in, they're taking over several hundred acres in that area we're talking about, and I've hiked that area. It's wonderful. It's full of wooded areas. It's wonderful habitat for our birds and insects. Hello.
Yeah.
And they're taking it, and then they've already been in there with the bulldozers, so they've got a done deal. They bushwhacked the
Yeah,
council.
and
I'm
if you
just
check, they got a
it's
tax break.
Great.
Follow the money trail.
Keep showing up.
Yeah.
But it's too late. They've already done it. For the damn thing.
No, you should be mad. You should be mad.
Chris, we're about out of time.
I know.
Wanna do your last slide here and give
Yeah.
us a little, what can we
No.
do?
Now,
You're leaders and soldiers in the long war. It's 100-year war. Because of the residence times, the time to adapt and the cost it's gonna take. You just can't do it overnight. I think what I have seen from the ones that are successes like Europe and stuff like that, it's bottom up. Everybody doing everything they can. The recycling, so you don't have waste, it's the energy savings, adapting renewable energy in places at your house level and up. It does make a significant difference. And it's the only thing we can do. Now, we would like a government that would support that kind of stuff, but the problem is You can't change every four freaking years. This, if it's a long war, you gotta do the same thing over and over again to start, just like it's your credit card. Well, now you gotta pay the credit card down. That means you have to take bites out of it all the time and get that balance down. Little stuff, everything, and make your vote count. We just can't keep. I don't know how, I'm very negative on the political system here.
Understandable.
You have to.
Well,
And I
Don't vote early and vote often.
often, yeah, the old Tammany
Uh-huh.
Hall thing. We gotta get it to be a priority, but it only looks like, only when it's nearly killing us personally, are we gonna address it, even when it's, taking you so you can't survive where you are and you have to mass migrate still. And I think you all have some good thoughts here, but, we're probably just, 200 million short of being able to get the number of people that we need to be on our side. So, I thank you all for coming tonight.